Hey guys, we're going to do the foldables. Okay, so there were two types of triangles, like our square cut in half, right? And our equilateral triangle cut in half. Okay, so when I look at this, the example we maybe pulled from our notes was if I had a square 5 by 5, we got a hypotenuse 5 times the square root of 2. All right, so this tells us that there's a pattern that emerges, and we got that with Pythagorean theorem. So the pattern is whatever this one side is, the other side is. Because notice how they're the same size angle. So if one side is 5, the other side has to be 5. And the hypotenuse is whatever that number is times the square root of 2. All right, what kind of a pattern emerges with our equilateral triangles cut in half? So if this was an equilateral triangle, like I said, that was a 60-degree angle. And you can kind of see that if we laid it on its side and cut it in half, then we end up having a small side opposite our 30-degree, a medium side opposite our 60-degree angle, and then opposite, this would be our hypotenuse, right? Our longest side. So we had seen that if our equilateral triangle was a 10 by 10 by 10, then this line, the altitude, cut this one in half, and it would be 5. Then using Pythagorean theorem, we found this medium side would be 5 times the square root of 3. It's a very interesting pattern, isn't it? So our small side ended up being 5. Our medium is 5 times the square root of 3, and our hypotenuse is just double that, right? 5 times 2, or 10. So these are the patterns that we see. Now, using our notes and this kind of refresher, I want you to kind of pause the tape and try to work through these if you missed class today. Okay, welcome back. Hopefully you paused it and tried that out. And so again, we need to think about what formulas do we have with our squares cut in half, right? We get one side, which we like to call x, and the other side would end up being called x because they have to be the same. And her hypotenuse is x times the square root of 2. This is what we oftentimes call the mathematical pattern or formula. So using that pattern or formula, let's see if, this one matches our notes, right? This would have to be 5, and that would have to be 5 because that's 5 times the square root of 2. So let's see, if one side is x and the other side is x, they also said to call that y, and our hypotenuse is x times the square root of 2. Here, the information they provided us was that the hypotenuse was 5 times the square root of 2. So notice, if we divide by the square root of 2 on both sides, we get x is 5, and that's exactly what we wrote. X is 5, and x and y are equal, and that's also 5. Now using this same formula, we're given the hypotenuse again, so we can set this up the same. And the hypotenuse is equal to 2 times the square root of 6. Oh wait, no. I think that's true, but the pattern is x times the square root of 2. So when we look at this, we say, well, wait a minute. I think that there's an x times the square root of 2 on this side as well, because I can rewrite the square root of 6, the square root of 2 times the square root of 3. This is going to be really handy because that way when I divide by the square root of 2, this will cancel. Isn't that interesting? And this ends up giving me x is equal to 2 times the square root of 3. So this is 2 times the square root of 3. That's 2 times the square root of 3. And again, what is this? Well, it's that side, whatever that side is, right? Times another square root of 2. So that's how they got, right? This is this side times the square root of 2. So that's how they got that answer. Now let's look at 2 more examples. Okay, so this is a square. So this would be a 9 by 9 square if you kind of turn your head there. And this would be 9 times the square root of 2. That matches our pattern. Here, let's see, one side is x, okay, the other side is also x, but we know one of the sides is 7 times the square root of 2. So that means Since it was a square, the other side has to be 7 times the square root of 2 as well. And so what is our hypotenuse? It's just x times the square root of 2. So if x is this, we can just plug that in there, right? So the 7 times the square root of 2 times another square root of 2. Well, that would be the square root of 4, which is 2. So we get 14. Now this should look familiar because if you look back in your notes, one of the first questions we did, this side was 5 times the square root of 2, that side was 5 times the square root of 2, and this ended up being 10. So there's a similar pattern there with these numbers that you should be kind of realizing. Okay, now how is the things the same or different with our equilateral triangle cut in half? So again, if this side is x, this is twice as big. So we have a small side. If we call the small side x, the medium side ends up being x times the square root of 3. And the hypotenuse equals 2 times x. So using this formula, side is x. Okay, side is x. All right, the small side. The medium is x times the square root of 3. So here our medium side is 4 times the square root of 3. So if we divide by the square root of 3 on both sides, we'll notice we could have used the pattern. X here is 4, so we should have seen the pattern. If that's 4, that's 8, and that's 4 times the square root of 3. So the hypotenuse is just whatever 2 times x is. So we know what x is, so we can plug it in there. 2 times 4 is 8. Okay, well, what else kind of follows that pattern? Well, we notice, oh, that matches our notes, doesn't it? We have here, that's 5, so that's 5. Here's my hypotenuse, that'd be 10, and this would be 5 times the square root of 3. All right, now these are a little different because my small side, so my small side is 12 times the square root of 3, which means my hypotenuse is just, right? Hold on. My small side formula is x. My medium formula is x times the square root of 3. My hypotenuse is 2x, right? But I actually know my small side. It's 12 times the square root of 3. So we know x, we can plug it in there. So let's just plug it in. 12 times the square root of 3 times another square root of 3. Here, 2 times 12 times the square root of 3. So the first one in would be 12 times the square root of 9, or 12 times 3 gives me 36. Let's look at our hypotenuse here. It says 2 times 12, would that be 24 times the square root of 3. Now, looks a little off, but if you turn these into a decimals, I promise it is a number bigger than 36, and this is a decimal smaller than 36. So 36 looks weird, but that is our answer. Okay, using those same formulas, here's our small, medium, and hypotenuse. So this is small is x. X is 7 times the square root of 3. The medium is times the square root of 3. So we know what x is. We can plug that in. 7 times the square root of 3 times another square root of 3. So 7 times 3 is 21. Nice. Okay, our hypotenuse is 2 times x. So once again, we could plug that in. So 2 times x. And x here is 7 times the square. So we get 14 times the square root of 3. Nice. That is your first foldable. Good job, guys.